All right, everyone. So by now you should have something that looks like this in ease, right?
Yes.
You should do that now, yeah. Anybody not get this far? Over there? Because if you're not this far, then... By the way, everyone, this is Jesse. Jesse's thinking of applying next year. So hopefully you're all this far and you've actually drawn the audience surfaces for the Friedman Theater. So now we're going to see how much farther we can get into this. So John, you asked the question last time about, hey, but the ears are like up above the floor, a certain area, and I said, yeah, we'll worry about that later. So now's the time to worry about that. So this is just a surface, okay? Actually, I mean, they call it a face in ease, and strictly speaking, ease doesn't really plot sound onto faces. I mean, you can make it do that, but it doesn't naturally want to do that. It wants to plot sound onto what they call a surface, and the implied part of that label is audience surface. So you have to create, you can define all kinds of faces in ease, but then you got to tell ease which ones are audience surfaces. There's a lot of ways to do that. The easiest way to do it is to do what I said, which is draw all of your surfaces with only 4 points. Figure out how to do that. And then watch carefully. I'm going to click on this face, and then I'm going to right-click on it, and I get this option that says Area Above Face. So if I click that, it is going to create an audience area directly above it. And you're saying, I don't see one. Well, let's go to the side here. See it now? See how we've got a face here, and then above it, an audience area. So what you ought to do is repeat that process for every one of your surfaces. Now, because we're still in mirrored mode, if you do it for one of your sides, it should replicate it on the other side as well. So now, if I look here, I've got little audience areas hovering above my surfaces, and that they're hovering at the height where the ears usually are. Now those audience areas is where we'll be able to plot sound. Mm-hmm.
My license is not letting me.
Okay, so did you try again? So did you run an update on your computer? Have there been any software updates on these machines? Anybody else having trouble with that? All right, so now what we'll do is, now that we have audience surfaces defined, now we can start plotting loudspeakers. So, once upon a time, before we shut down that building across the street, we used to have some equipment set up, a couple of loudspeakers that we would leave. So let me show you where it was. It was hanging right off of this catwalk, kind of there-ish. Okay? Right in the center. So here's what I'm going to do. And I happen to know it was a D&B Q10. Okay? So let's put one in there. So over here on this left area, you know where you were doing inserting vertices, inserting face. Well, the one right below face is insert loudspeaker. So if you click on that, and then again, just click anywhere in here, doesn't really matter. And now we're going to put this in the spot where I'd measured, which in this case is minus 4.5311 on the Y. X will be 0 because this particular loudspeaker is on the center line. And height is 24.5880. Okay, so you guys have really got to stay with me. You can't be having side conversations when I'm trying to show you something. Okay, so that's when you stop and you ask, okay? Don't ask the person next to you and then have a conversation because I'm going to keep moving on, okay? So if I lose you, stop me and then I can answer your question. So where are we stuck? Okay. So I hung it straight off of this catwalk closest to the upstage wall here, and I hung it, I just arbitrarily plopped it right there, which happens to be 24.5880 feet up off of the deck. Okay? Everybody got that? Okay. So then I went over to this insert loudspeaker and I clicked just anywhere in my edit window. Doesn't really matter where. And I was given this pop-up screen. You see that? Is everyone at least this far? Is everyone looking at this pop-up screen? All right, so what you got to do is in this point of reference area right here, you got to put those XYZ coordinates. This is where the loudspeaker is going to sit. Yours might be slightly different than mine based on where your point was or whatever, but it should be pretty close. Now I got to decide which sort of loudspeaker this is. So remember what I said it was? D&B Q10. So where it says speaker model, you're going to click on this little button next to that field. And here are my available loudspeakers in this project. None. Okay. There's one that's called a sphere, and what a sphere is just like it's just a generic noise source that sprays sound equally in all directions. It's kind of fun to play with, but not exactly what we're looking for. So instead, you're going to hit this browse button. And so remember all that time that we spent downloading and installing this database? We were downloading and installing, basically every loudspeaker that's ever been made in the history of time, which is why it took so long. So if you open that up, you'll go. It's right here in that select speaker. So hit browse. And then you'll have this global speakers. And what you'll see is as you scroll through here, you've got all these different manufacturers. Okay? And what you're looking for is, in this case, D&B. Now, there's two different ways that you can get loudspeaker files. You can use these ones that come with ease, and in most cases those are coming from the manufacturers. The manufacturers are sending this data to ease, and then they're bundling it into the software. But it's not always the case. Sometimes these are ones that other people came up with, or maybe ease came up with, or whatever. And if you ever have any trouble with these files, you can also usually download them from the manufacturer's website. So if you go to like DMB's website, you'd be able to download a package that you could install on the computer that would have ease files from them. So if you ever run into any trouble with the files, try getting the ones directly from the manufacturer. So if I double click on this DMB, yeah. So ease is a proprietary format. So that would be a very specific download just for ease. There are other file formats, for other programs, but you would specifically look for the ease files. Okay, so now that you open the DMB folder, I've got different product lines for DMB. We're looking for the Q series, which is right here. Not the Q series arrays, but just Q series. And you'd see we have a few options here. Now I said it was a Q10. You've got two options for Q10. Why do you suppose we have two options? Yeah, because the Q10 actually has a rotatable horn in it, and when you rotate the horn, that changes it, but it's not the same thing as rotating the box, because when you rotate the box, it changes the orientation of the two load drivers relative to the horn. So there's actually 4 different ways that this particular loudspeaker can be directional. So just for now, let's go ahead and add both of these Q10s into our project. And while you're at it, add the Q7s as well. Once you've got them all over here into the project database, then you can hit close. And now in your little select speaker dialog, you've got all these different ones. So let's take this one that says 11 by Q10 11 110 by 40. And if you open up details, you can kind of see, it'll show you the max SPL. It'll also tell you the directivity index, which are things that you should be familiar with. And look at you can look at the difference here between the two. The frequency response is the same, but the directivity index changes depending on which one you're using. Okay.
How do you know what directivity index is talking about?
I don't know. Yeah, so there's other ways to look at this. So let's go ahead and get the 110 by 40 for now. And now that you've got that selected, you see you've got properties in here. These are all different things you can look at about the loudspeaker. Okay. Another thing you'll see here is under SPL, you've got different frequencies and their power and SPL output. What I would recommend doing is go ahead and click this button that says all to max. And what that's going to do is it's going to set every frequency in ease to be plotted at its maximum level it's able to do. So in other words, you're putting the loudspeaker up at its full performance. Start there, and then you can work your way down if you need to turn it down. So hit that all to max, and it'll pop everything up to where you want it to be. And you can turn on these coverage cones if you want. I don't usually like to do that, but you can if you want to. All right, so hit apply, and then hit OK. And now here we are. Ah, you saw that. So I'm gonna try and do something. Yes, you got a red light, and there's a reason for that that I'll show you in just a moment. because here's what's going to happen. Now that I've got this in here, let's just try to save this project. So, because this is now you've edited this room, so go ahead and hit save. And you get this error that says, I ran into a problem. Because when you save in that room edit mode, it does, one of the things it does before it saves is it goes and it just checks your work, right? It looks at everything you did and to see if there's any problems with it before it saves it. And if it finds a problem, it tells you. And in this case, it found a problem. It says, you've got an asymmetrical speaker model in a symmetrical room, which I don't really understand why that's such a big deal, but apparently it is. And the way that you know that is, so I'm going to hit cancel, I'll come back in here, and if you go back to this thing where you see, where you're selecting loudspeaker, and you see where it says, this is the reason why I opened those details, see where it tells you symmetrical is no. I don't fully understand what, like I say, what the big deal is, but this room is drawn symmetrically, right? You only drew half of the points in this room and half of the surfaces in the room. The other ones were created automatically for you, mirrored across the center line. Remember that? Remember when you did that? Okay, so, and that saves you a ton of time for drawing, but you can run into problems with that when you start putting certain loudspeaker models in here, because just the way that that data is organized in that loudspeaker file makes it really difficult for ease to plot the data. I suspect, and I don't know this for sure, but I suspect what's happening is there's one of the ways that the ease loudspeaker format can be set up is you don't have to put values in for the full 360 degrees on every axis sphere. You can just do kind of what they call a quarter sphere, and then tell ease to infer the rest of the coverage based on what's in that quarter sphere. And I think that's what's happening when they say it's asymmetrical in a symmetrical room, is that they don't have, there's something about that quarter sphere symmetrical data that makes it not able to calculate that. I don't understand why fully, but it is.
When you're plotting loudspeakers, can you also draw it symmetrically? Like, can you just put half the room of the loudspeaker and just run it?
Yeah, so watch what happens if I go back to the properties of this loudspeaker. Let me put it over like 20 feet on the X and hit apply. Notice how it makes a copy of it over there?
Wouldn't that also be a reason for the error message if you're plotting two loudspeakers with symmetry on ground top of each other?
If it's on the center line, it doesn't make a copy of them.
Okay.
This is a problem with this particular loudspeaker file. You won't have this problem with every loudspeaker you put in there. There are symmetrical loudspeaker files that you can use. It's just this particular loudspeaker, just the way that they've put the data in there, is not compatible with a symmetrical room. So never fear, there's a way around this problem. So I'm going to put this back on center line. You basically have to turn off your symmetrical room in order to fix this problem. So if you click off of everything and then right click in this area and open up room data from that menu. I'll go back. So nothing's selected. I'm going to right click somewhere in the room area and you're going to select room data. And you get this little pop-up window. So you see this little checkbox that says room symmetric? You're going to uncheck that. Room data. First one on the list. Okay, so you're going to uncheck that option that says room symmetric. Now what's going to happen is when you hit OK, it's going to give you, I think it gives you an error message, we'll see. But what it's going to do is all of those points that it sort of made automatically, it's going to say, hey, what you're about to do is to make all those implicit points into explicit points. So they're no longer just going to be mirror images. There's now going to be like you just drew them. And you no longer will have that feature where you draw something on one side of the room and it will mirror on the other side of the room. The second you hit this, there's no going back. You can't go back to the symmetrical version because it's going to eliminate all that information. So you've got to make absolutely, positively, 100% sure that you have drawn the room the way you wanted to draw it, and you're never going to want to change it. Because if you do want to change it, it's going to take you longer to change it because you're going to have to draw all the points. It's not going to mirror them for you anymore. Okay? The other option here is called room open. You're going to want to leave that checked. Okay? Because if you uncheck that, then it's going to require you to draw every surface in the entire building before it lets you plot anything. You have to make it completely airtight. No holes at all before it will plot anything, which is not particularly helpful for the kinds of things that we're going to do, because that would take you way more time than you have. So keep that room open box checked, just to say, hey, this is an open room, and I understand that that limits me, but I'm fine with that. But you do want to uncheck that room symmetric. Now watch what happens. I'm going to hit OK, and it's going to say, hey, guess what? You just changed your room symmetry. But turning the project size is going to take a few minutes because it's going to have to go through all those points and make them explicit. Say, yeah, let's go for it. Okay, did it. So now if you click on this surface, for example, it just says F4, as opposed to, as before it said, it would say F2 star, because it was a copy of F2. But now these are all explicit, okay? And the other thing you've got is now your loudspeaker thing here has all its points visible. So this is where you're going to want to turn off your vertices, which is up here in this top right corner. If you just click that, then it'll make all those little dots go away and you can see everything a little bit better. Okay, so now if we try to save, no problem. Went right through, and now it's freaking out over in the main window. You got to go over there and save there as well.
Is that actually that challenging of a thing that they were like, yeah, let's not program it. If we hit save it once, we can save it all of them?
Well, remember, ease is not just one program. Ease is like 20 programs. You know, this looks like different windows to you, but it's actually different programs. Yeah.
Should I plot that plane you made earlier in AutoCAD? In the AutoCAD?
Well, I'm going to make you guys do something different. So I'm just taking you through sort of a demo right now, and then you're going to delete these ones and do your own, and as part of your assignment. Okay. So don't worry too much about the specific locations.
Gotcha.
All right. So one thing you might notice here is. You can now see the box, okay? Because part of the ease file format is you can see the box, so it's laying flat here. And if I was going to try to let me look at the plan view. If I'm going to try to cover this area, given that this is a 110-degree horizontal by 40-degree vertical loudspeaker, where would I want the 110 degrees and where would I want the 40 degrees? Yeah, I would want the 110 on the horizontal and the 40 on the vertical. So let's see what we've got here. So now that I have this, the first thing I'm going to do is click on this loudspeaker. I'm going to right-click on it and select Loudspeaker Aiming. See that? Loudspeaker Aiming. And it brings this view up for you. Now, what you're seeing here is your head is now inside of the loudspeaker, staring out towards the seats, okay? And these lines represent 3 dB down points. So, given what we're seeing here, is this the correct orientation of the loudspeaker for our application? No, it's not, right? Because we want the wide part of it to be on the horizontal, okay? So let's close this for now and we'll fix that problem. So now we're going to right-click on the loudspeaker, hit Properties, and over here on Angles, you have horizontal, vertical, and rotation. So horizontal, angle would be, this sort of thing, changing it this way. Vertical would be this way, and then rotation would be doing this, okay? So we want to do, for rotation, we're going to put 90, because that's 90 degrees. Is how much we want to rotate this thing. Then you can hit Apply. Notice how we got the green light now, because now we don't have that symmetry problem. And you should see now that the loudspeaker is now sitting in a vertical orientation.
Does it change anything if you would hit 270 instead of 90? So it went from here to here, but if it went from here to...
Yeah, if you
Does
do
that
270, if you do 270, instead of going like this, it would go, right?
Well, if you hit negative 90,
That would work
if
too.
you flipped it the other way, does it matter?
No.
Okay.
In this case, no. Some loudspeakers, yeah, depending on how they're designed.
If it's like a 2-driver loudspeaker.
Yeah, it would matter, yeah. But this one has 2 low-frequency drivers that are on opposite side of the horn, so this versus that is not, it doesn't really matter. You know, it's the same thing. Okay, so now let's right-click on it again and do loudspeaker aiming. And now this is looking more like what we would expect, yeah? So now what we're going to do is where do we typically want to aim our loudspeakers? Back row, right? So this little crosshair is where it's currently aimed. So I'm going to click down a little bit so I'm closer to the back row. Okay? Let's see how this goes. So now that that's there, I'll close this. We're going to save our data. And now the other program freaks out and says, hey, you got to save there too. I say, yeah, I'm going to save there. So now we have a loudspeaker, we've got audience surfaces, everything's saved, everything's validated, the data's good, no errors. So now it just might be safe to start trying to plot something, okay? So to plot and see what this loudspeaker is going to do, we have to go back to the main ease program, and we got to launch a new program. So under calculations, which is right up here, you're going to do, there are 2 options that you are going to do, room mapping or area mapping. I prefer area mapping if at all possible because it doesn't spend a whole lot of time worrying about the 3D orientation. It just sort of does a plan view of the surfaces. The only reason why you might end up wanting to do the room mapping is if you've got things that are surfaces that overlap on that plane and looking at them straight down, you wouldn't see them. That can sometimes get weird, but I prefer area mapping. Yeah, because area mapping allows you to plot the data in ways that I think is easier to read. It doesn't look as pretty, but it's more meaningful, and I'm much more interested in it being meaningful than pretty. Okay, so we're going to select area mapping. And it launches a 3rd program over here, which is called the standard mapping program. So we can make this a little bit larger. And here we are staring down at our theater, at our surfaces of our theater from the top. And you've got this row of tools here that do lots of different things. So let's just step through them real quick. So here's one that would plot loudspeaker overlap. It would show you how, to the extent to which the coverage overlaps for the loudspeakers. It has nothing to do with level or anything. It's just going to plot that. Okay. Critical distance. Remember what that is?
Yes. When the reverberation is the same as the actual...
Yeah, so ease will tell you where the critical distance is in the room, but only if you have built the whole room with all the walls and everything so it can plot reflections. Then it will actually figure out your critical distance, which is kind of cool. We don't get to do that one because we didn't draw the walls, okay? This one's called direct to reverberant ratio. So this is similar to critical distance, but it's just telling you what difference in level the direct sound is to the reverberant sound. Again, we don't get to do that one. First arrival. This is going to tell you which of the sounds got there first. That could be helpful to us. If you think about plotting precedence imaging, it could tell you which loudspeaker arrived first at all the different seats. That'd be cool. First pause. I believe that is basically the second arrival. Direct SPL, that's the one you're going to use the most. Okay, direct SPL is just going to plot the sound that comes directly from the loudspeaker and hits the seats without bouncing off of anything. But you've got other ones here too. Total SPL, that would be the direct SPL plus all the reflections all summed together hitting the seats. Okay, We don't get to do that one because we didn't plot the walls, so we're not doing reflections. And then all these other ones are different acoustic things like clarity. You've got different level things. You've got speech transmission index, articulation loss. These are all things we can't do because we didn't do reflections, okay? Those are all acoustic measurements. So in this case, we're going to do direct SPL. So just hit this one. That's direct SPL. I guess it's supposed to be like a stick figure with an arrow pointing at their head for the direct sound that's hitting them, I guess.
I guess like so you can put like a talk on stage and see if you is that like something you can do like put a talker with a stage would be, so to say, and then figure out where the first.
Yeah. Well, you basically could put a loudspeaker file that would disperse the same way that a talker would, and so there's no. You can't put a talker, strictly speaking, but you can put a loudspeaker that behaves like a talker, right? Okay, so we're going to hit direct SPL. Okay? And it gives you this sort of pop-up thing. And it's going to say, all right, what do you want? How do you want to do this? Well, the first thing is you got to tell it which loudspeakers you want to plot, okay? So where it says loudspeakers in use, currently it says none, which means if you try to hit OK, nothing's going to get plotted because there's no loudspeakers involved. In most cases, you're hardly ever going to plot all of your loudspeakers all at the same time because that's usually not very useful information. You usually want to look at them one at a time or maybe as an array or something to just see what they're doing. So go ahead and hit this loudspeaker button, and you've only got one, so just select this S1 and hit OK. So now we know it's going to plot S1. And then, you know, on items, you can say, where do you want it to map? We're going to say on areas. And it's going to say, which audience areas do you want to plot on? And right now, it's got them all selected, right? And if you click on the box, you'll see that they're all selected. But if you only want to plot on one of them, like if you only want to focus on that center section for a little while and not have to plot on the sides, you can turn those off.
So that's only pulling up, like the A's were all of the ones where we put them above the first ones. There's no F's in there. Why are like?
Because it doesn't plot on faces. It only plots on audience areas.
Oh.
So what's the on seats?
On seats,
Only
that
inserted
so you
seats?
no you can so you can insert seats in ease. I've never found that particularly useful, but you need that to do the ears thing, which lets you like put headphones on and listen to what it would sound like. But you have to build all the walls to do that, and we're not doing that. Okay, so on areas. You can use the seats to just have something you can click on, and you can click on that and say, what does this person hear, right? And it would pull up all these graphs and say, oh, this is what they hear, right? I don't find that very helpful most of the time. Okay, noise, you can actually introduce a noise level into this. Again, not super helpful for our case because we're not plotting things like articulation and things, so not super important, so just leave that alone. Calculation, this is kind of important. So the one that you're going to want to be careful of is this interference thing. In our case, it's not a big deal because we only have one loudspeaker, but if you have more than one loudspeaker you're plotting at a time, if this box is checked, it's going to try to tell you how those loudspeakers interfere with one another at the listening plane, which sometimes is helpful, but sometimes is not helpful. So you've got to sort of pick your battles there. We'll give you the different scenarios. But essentially, it's going to plot the comb filtering, which sometimes can get in your way because not all comb filtering is bad. But ease is not very good about telling you the difference between the good stuff and the bad stuff. So if you have that turned on, sometimes it'll just show you a complete mess. And you'll think, oh, this will be awful, but in reality, it's fine. Okay, so I'm going to go ahead and turn that off for now. It doesn't super matter because I'm only plotting one loudspeaker, but just to clean things up. Okay, and then we got to decide which axis or which frequency we want to plot. I'm going to plot 500 hertz, and the reason I'm going to plot 500 hertz is that I need to figure out if I've got the right loudspeaker file loaded here. Because the interesting feature about this particular loudspeaker is those double drivers. And on whatever axis those are lined up on, this loudspeaker gets directional at 500 hertz. Okay, and what I want in this case, if I'm going to use this for like when I'm going to have mics on stage underneath that loudspeaker, I would like that 500 hertz to be directional on the vertical axis. Okay, so I want to make sure I've got the right file that does that, because for this orientation with this horn rotation and everything, I want to make sure I've got the wide coverage on the horizontal and the narrow coverage on the vertical, and 500 hertz to be narrow on the vertical. That's what I'm looking for. So I'm going to plot 500 hertz and see which axis 500 hertz is directional, and then I'll know if I've got the right file or not. Okay? So I'll click OK, and then I'll click OK again, and here it goes. It's plotting, and it did it. We can sort of now move some of this stuff out of the way so we can see what's going on. And let's see here. There we go. So there you go. There's a couple things that I would recommend changing here. One would be instead of showing patches like this, which is the grid, I would turn on this thing that says ISO lines. What ISO lines does is it actually shows you a line every time it changes 1 dB in level. Okay? And I think that's helpful because that's easier to count, because you're ultimately looking for when do I go to 6 dB, right? So I think that's useful. Now, the good news is it looks as though 500 hertz, I am narrow on the vertical. You see that? So I think I've got the right file in this case, which is good. So you can see how, now that I've plotted this, I've got, 97, and then count it to 6. So 1, 2, 3, 4, 5, 6. I'm pretty much there. Yeah. So now what I want to do is let's see what the other frequencies do.
So is it just something with Q10 that like if you have the direct SPL that 630 hertz there's a drop of 10 dB? Is that just something Q10 does?
You talking about this?
Yeah. On the left side, like the graph.
Yeah.
It's that was just
Well,
the above it is 12 dB higher and below it's
well, this is showing you the direct SPL at a very specific location. Okay, so you could click around a little bit and maybe get some different locations, but right now, that's what it's showing you at A1, which would be whatever your audience area 1 is, and it gives you the coordinates for where that is. So that's not necessarily the whole thing. But if you turn on this average, this is basically showing you frequency response across that area. So you can turn on different things, maximum, minimum, so on and so forth. Current position is just like where your thing currently is. And you can change that. I believe it's this little, is it this one, or it might be here. I'm not sure. I've honestly never paid a whole lot of attention to that. I don't find that helpful. But yeah, there's probably a little bit of dip there because that's where it starts it's interacting with those low drivers. And that is just particularly the case for this particular spot that it's plotting that frequency response for. But again, I wouldn't worry too much about that yet.
I can toggle on and off the key. Because on mine, I don't know what I did, but now
Well, mine was off for a minute there when I resized the window.
yeah,
But
that's what I did.
then when I switched to ISO lines, it came back on.
Okay.
So I would toggle back and forth between the patches and the ISO lines. Okay. What? I don't find that all that useful, just because it makes it too pretty, and it's hard. I want to know exactly when I've dropped 6 dB, and it's hard to really tell that if you don't have some sort of reference for that. So I think the hatches makes for a prettier rendering, but I'm not so much concerned about that here. But maybe if you were wanting to show this to somebody who isn't going to understand what the lines mean, and they just like pretty things, then maybe plot it to show. I've had to do that every once in a while, where I've had to just like show somebody that I did something cool, and that it's not important to me whether they understand what it means. But I prefer the ISO lines. I find to be way more useful, and you can't do the ISO lines in that room mapping view, which is why I like the area mapping app instead, because I can do the ISO lines. So let's start looking at some other frequencies, right? Because that's important. This is 500 hertz. Let's see what else we've got. So if you right-click, if you're just actually click on this 500 hertz thing over here and select 1000 hertz and click OK. And then you're going to click this little render map button up here. It'll re-render it for you at that frequency. Okay? So there's 1000 hertz. And so now maybe I'm starting to think maybe this loudspeaker isn't the best, right? Because I'm way past 6 dB. So let's try 2000 hertz and re-render. It's getting even narrower. See, I think I've got the wrong file here. Let's try 4000 hertz. See how it's getting narrower? So I think whatever that visual reference was that I was seeing when I was aiming, I think that was wrong. I think I need the other file in order to get, because I know that I've got the 500 hertz on the right axis, but now the horn is not in the right orientation, right? So I need the other file. The other file has the horn rotated differently, which now when I roll the loudspeaker will get everything lined up the way I want. Because this does not look like a horn that is 110 degree horizontal to me. So let's go back. I'm going to close this little plotting app, and let's go back to our room editor. We're going to select the loudspeaker, right-click on it, go to Properties, and for speaker model, I'm going to switch to the Q10 40 by 110 as opposed to the 110 by 40. I'll click OK and apply, and click OK, and then save. Let it freak out over here. We'll save again, and now let's go back to area mapping and plot this thing again, see if we can get any better results. Plot direct SPL. Everything else should be the same. I'm going to keep it at 4K for now, and let's plot it. Hey, that looks like something. That looks like more what I had in mind. So now let's go to the 500 hertz again and make sure that that is still behaving the way I want it to. And it looks like it is. 500 hertz is still looking narrower on the vertical than it is on the horizontal. So I've got this pretty well solved now. So let's go back now to that 4K, plot that, and let's see if there's anything we want to do. So one thing I would notice here is, you see how it's kind of fallen apart here on these extreme edges? So I might actually want to tip this down a little bit. Something about this particular angle and everything. I'm not quite getting my full bang for my buck on that back row to front row thing. So yes, the back row is like the rule of thumb, let's start there. And now we've looked at it, realized, oh, I could go a little bit further down than that, and I think I'd get a better result. So let's go back over to our room editor.
Do we need to X that up?
You can leave it on because I want to show you there's a thing that's going to happen. So right click on this. We're going to do loudspeaker aiming again. And let's just click this a little bit further down. Go a little further down, and then click, and then you can close this. Now watch what happens when I hit save. So I'm going to hit save. The main window freaks out. We hit save again. And now if we go back to the area mapping, you notice how there's this yellow outline around my area. That's your clue that's easiest way of telling you that it knows you changed something. So it's saying, hey, what you're plotting right now does not reflect the current configuration of the system. So what you have to do is you have to go up here, and you see this little button that says Acquire Data. You can also get that off of the File menu. Go to File, Acquire Project Data. What it's going to do is you're going to tell it, hey, go and check the file again and see if there's any data that's different. So hit that, and it'll say, okay, I found some differences. Do you want to recalculate this thing you've mapped? And you say, yeah, I do. Click OK. It's going to ask you again if all these parameters are still the things you want. Say, yeah, they are. And now it moves it. Okay, that looks better, right? I don't think I want to go a whole lot farther down than that, because now I'm running up into my 6 dB down at the back row, which I don't want to be. So this would be, a really good example of where I would want to maybe put a fill in over here. Or I could take this loudspeaker and move it a little bit further upstage to widen it out a little bit. Right? There's lots of things I could maybe do to sort this out. But this is a heck of a lot quicker than trying to figure all that out manually like you guys were doing before, right? So that's what computers are really useful for. Computers are not very useful for, doing things for you that you don't understand, because then it's really hard to get it to do it. But if it's something you already know how to do, and you just need it to be done quicker and more accurately and more often, computers are that's a really good thing to use a computer for. So in this case, you know how to plot this all manually with a paper and a pencil and all of that and a calculator. You just want a computer to do it quicker. It's great. This is a good thing to use it for. So here is what I want you to do. I would like you to essentially do what I asked you to do before on the paper project. And you guys, you can go ahead and do the Friedman. So I don't have to make you redraw the the arena. So basically, just design me a center cluster for this, but you can't do this one because I just. So yeah, what I would do is the same thing. I want 2 options, right? So. Give me 2 options. One would be maybe the one you thought was the best option from your paper project, and then now see if you can find a better option than that, okay? But we're looking for a center loudspeaker or center cluster that would cover this area pretty well, but you can't use this Q10 because I already gave you that one, okay? And you've got about 30 minutes now to start working on that and see what kind of issues you run into, and I'll help you with those problems when you run into them. And then on Monday, what we'll do is I'll show you, if you can come Monday with that done, then we can talk through about, okay, now how do you sort of format this data so it looks nice? How do you then save it as graphics that you can put into AutoCAD? All of that kind of stuff, all right? So start now figuring out a center cluster, 2 center clusters actually, and then we'll go from there. Yeah.
So do we need all of the other numbers as well, like the Excel sheet, or just this graph?
No, this will do that for you. That's the whole point.
Can we hang from the same spot?
You can hang anywhere you want.
Just the only thing that we're really changing is the aiming and the speaker we're using.
Well, I mean, part of this project is to figure out where's the best place to aim it.
Oh yeah.
Right, or to hang it, because like this is actually not a really ideal spot because the stage comes out way in front of that.
Okay.
So there's an argument to be made that maybe a better place to hang it would be all the way out here. But that does make for a really steep vertical angle for these people in the first few rows for the way they perceive that sound. So play around with it, but don't worry about that for now.
So we don't have to be locked into like how the building is or was.
Well, there's plenty of roof steel across here, so you really, in this space, you really can hang just about anywhere over the stage. Some locations would be a bit more complicated than others, but it could be done. So for purposes of this, just assume you can hang anywhere and try to figure out a center loudspeaker or loudspeaker cluster that could cover this whole area. Okay? I've given you just enough information to be dangerous now. So start goofing around with it. Save often. And start working on it now, so when you run into issues, I can answer your questions.
Is there like an auto cap? There's the auto save every, like I've got mine set to 2 minutes. It auto saves. Is that not an option on the CD?
I don't know. I've never.
Yeah. And also, why? Out of curiosity, why did? Because I know they used to use Laura, and now we use Ease. What was wrong with Laura that Ease does that Laura doesn't?
So Laura is another application that it does a very similar thing to Ease. And actually, Laura was created by somebody who was frustrated with the complexity of Ease. I just felt like Ease was trying to do more than he really needed, right? So he created this program, Laura, to do it. And the main thing was, it's like he didn't care about walls and surfaces and reflections. He just wanted to plot direct SPL. And this was before manufacturers started creating their own software for these kinds of things. So it was a lot cheaper than Ease, and it was a lot simpler to use, and it gave relatively good results. And what he had done is he'd figured out how to read the Ease files, so you could use Ease loudspeaker files in Laura. But what happened is, the people who make Ease were not super happy about that, and so they kept updating the Ease file format for the loudspeaker files, and then they had to be kept getting reverse engineered to try to, how do I read these things? And eventually they've got it locked down pretty tight now, so it's really hard for third-party people to read the Ease data files. So that was one problem that started happening with Laura, was that it just wasn't able to use the most current loudspeaker data that's available because it just wasn't being published. And there was an effort that was made by the guy who makes Laura to, he led a group to create what he called a common loudspeaker format, just sort of an open format for digital loudspeaker data. They're called CLF files, and tried to get a lot of manufacturers to publish in those, and some have, a lot have actually. And so Laura could read CLF files, but it's just still not all the manufacturers are publishing CLFs, but that was helpful. But then kind of what started happening is, he basically hasn't updated that code in 10 years or more. And so we're starting to run into some compatibility issues as well. So we were always, for the last several years, we've been kind of limping by with that tool, trying to keep it working. And it just got to the point where we were having enough compatibility problems, both with the loudspeaker file formats and just being able to run the software at all, that we finally said, well, let's just go over to Ease. It's more expensive, but in the meantime, Ease got a lot easier too. They started listening to a lot of the feedback, and now you don't have to draw the whole room. You can just draw the audience areas and plot like this and get results pretty quickly. That wasn't always the case, so that's why. But the main advantage of Ease and Laura was that it was no respecter of manufacturers, basically. It would let you plot systems that included loudspeakers from multiple manufacturers, which is difficult to do using the manufacturer-specific plotting tools. Meyer's map only lets you plot stuff that Meyer makes. D&B Array Calc only lets you plot stuff that D&B makes. And honestly, it's only the stuff that they've made in the last 10 years that you can put on Array Calc. Because they want you to buy new stuff, and so they're not going to, make you very comfortable using old stuff. All right.